Alright, let's quickly run through another example. Find the derivative of y is equal to 2x squared from first principle. The question is, y is equal to 2x squared. Let's call this equation 1. Now, from equation 1, let's add changing y to the left-hand side and changing x to the right-hand side. So we'll have y plus changing y to be equals to 2. Open brackets, changing x will give me x plus changing x. Remember, it is all squared. All squared.
Y plus changing y to be equals to 2 open bracket x squared plus 2x changing x plus dx squared. Alright, let's leave the left hand side as y plus changing y to be equals to, expanding here, we have 2x squared plus 2 times 2, 4x changing x plus 2 times the x becomes 2 dx squared. Let's call this equation 2. Therefore, subtract equation 1 from equation 2. And equation 2 is y plus changing y. From the left hand side, we subtract equation 1, which is minus y, to be equals the right hand side 2x squared plus 4x changing x plus 2 changing x squared. Subtract equation 1 as well, which is negative 2x squared. Positive y cancel negative y. Positive 2x squared cancel negative 2x squared. Then I'll be left with changing y to be equals 4x changing x plus 2 changing x squared. So divide both sides by changing x. That gives me changing y over changing x to be equals 4x changing x over changing x plus 2 changing x squared over changing x. Changing x cancel changing x. Changing x squared divides changing x to give me changing x. Therefore, we'll have changing y over changing x to be equals 4x plus 2 changing x. So, take limits as changing x approaches 0. Taking limit on changing y over changing x as changing x approaches 0 becomes dy dx. When you take limit, changing y over changing x becomes dy dx. Now, equals 4x remain 4x, then plus 2 changing x. Changing x, remember, approaches 0, so it will be 2 times 0. Therefore, dy dx becomes 4x plus 0. That leaves us with dy dx to be equals 4x.